Hi. In bioinformatics, pairwise alignment algorithms are used to find global and local alignment between different sequences. In this video, I am going to talk about alignment algorithms. So, alignment algorithms are computer programs that guarantee to find the optimal alignment between two different sequences. So, algorithms differ in optimization strategy used for different aligning two different recipes. So, we have different types of algorithms which can be used for alignment, and based on our applications, we should use different algorithms. So there are three different types of algorithm which can be used for local alignments, which includes dot matrix method, dynamic programming method, as well as the word method. And I am going to give a brief idea about all of these algorithms. First one is dot matrix method. It's a graphical way of finding similarities between two different sequences. What we are doing here is like we are writing one sequence in the x-axis and another sequence in the y-axis, and we are looking for the similarity. If you see a similarity, we are going to put a dot here. If it is not similar, we will leave the place blank. So every dots in this matrix is actually representing similarities between two different sequences. Here you can see it is a T and it is a T. So they are the similar. We will put a dot here. So all the dots in this figure representing a similarities between two different sequences. So after making this matrix, after filling all the dots, what we are trying to do, we are trying to connect the dots diagonally. A diagonal line in this dot matrix representing a similarity. So you can see that this diagonal line is not uh, like there is no straight line from one diagonal to another. This is not connected. So here, in order to get a diagonal line, we need to move vertically. So vertical or horizontal movement in the diagonal line representing a gap means an insertion or a deletion, just like the gap we are introduced in the sequence alignment examples. So we are trying to find the best diagonal line which connecting two different sequences. So here we will start from here and we will jump here and we will continue. So if the diagonal line is uninterrupted or minimally interrupted, that means that these two sequences are very much related. If it is not that much related, the line will be broken. So substantial regions of similarity is when many dots line up to form the continuous diagonal line, and interruptions means the horizontal or the vertical movement of the line means an insertion or deletion. It can be used to find the internal repeating elements because it also show the diagonal lines. This means an internal repeating region. Okay, then it is actually give a visual representation of the similarities between two sequences. But the thing is that this method cannot be used if it cannot be efficiently used in bioinformatics, because this one is more like a visual method, graphical method, rather than a statistical method. So in this method, it is very difficult to compare large sequences, because to make large graphs and everything is difficult, and noise level is high. If you are not using the filtering window, the noise level is very high, and so in large sequences it is difficult to find the true alignment between two different sequences. And most important limitation of this method is like it lacks the statistical rigor. It's not a statistical method, it's a visual method. So this method is only limited to the pairwise alignment. It is very difficult to do the dot matrix method in the multiple sequence alignment. There are examples for this dot matrix algorithms which can be used for alignment, which include dot helix and a matrix plot. So these algorithms are based on dot matrix principle to find the relationship between pairwise alignment between two different sequences. Next method is dynamic programming method. It's basically a statistical method. It determines the optimal alignment by matching two sequences for all possible pairs of characters between two different sequences. It actually produces a two-dimensional grid with quantitative scoring between for both for the matches and mismatches. This is actually using a score matrix, and based on the scores we are finding the alignment. So it's basically a statistical method as well as a quantitative method. So how we are calculating the score? So score of a cell is actually determined by three neighboring cells. So the score from these three neighboring cells will be added to get the score of this cell. So if we'll take the score from this cell plus this one will be our score of the one cell. Okay. So if I give an example, this is a simple example. In x-axis we put one sequence and y-axis we put another sequence, and whenever we see a similarity we will put 1. If it is not similar we will put 0. Okay, so that's very simple. For the next column row, what we do, we take all three of them and add up, and the score will be this one. Okay, so it is 1 because we add 0 plus 1 plus 0, it is 1. Okay, these two sequences are dissimilar, so there is no addition. Next one also 1 because we are adding these 3. This one we get 2 because we are adding these 3 and we will get 1 because this G and G are similar, so it has a weightage of 1, so 1 plus 1 is 2. Here we are going to get a 2. Okay, like that we are completing the grid. Once we complete the grid, what we do, we move from the bottom to top in a diagonal way, and the thing is that this diagonal line which is actually producing the highest possible value, highest score, will be the best alignment between these two sequences, and based on this one we are making alignment like this. So we can draw like this, and the horizontal movement or the vertical movement in this grid actually representing a gap. Okay, here we have moved in vertically, that means a gap is introduced here. Okay, so it constructed two-dimensional matrices, and based on the score matrix we are actually finding the alignment between two different sequences. So the best matching path is the one with the maximal score. It can be used for both global as well as local alignment. And in this one what we use a term called gap penalty. The gap penalty representing insertion or a deletion. In terms of evolution, the chances of insertion and deletion is less than the substitution. So whenever we are making a statistical program, quantitative program, we take that into the consideration. Whenever we are adding a gap, insertion or deletion into the alignment, we should be more careful. To convert it into a statistical terms, we are introducing something called a gap penalty. If we are introducing a gap in one sequence, we should reduce some score from the overall score. So in the previous figure, we actually selected this path based because it is the one which is leading to the maximal score. So when we are moving horizontally, that means we are introducing a gap here, which is a unlikely event when probability of happening an insertion of deletion is low. So to take that into account, we are introducing a gap penalty. So gap penalties are minus score given when introducing a gap. When the path move horizontally or vertically, the penalties will be applied. Okay. And this method, the dynamic programming, can be used for both global as well as local alignment. The algorithm called the Needleman-Wunsch algorithm is a dynamic programming based algorithm for global alignment. It is suitable for aligning two closely related sequences. Smith and Waterman algorithm is a local alignment algorithm which is based on dynamic programming. If distantly related sequences are comparing, we can use this Smith-Waterman algorithm. So the dynamic programming can be used for global and local alignment using specific algorithms. The final method is the word method. The word method, also known as K-tuple method, it is a very efficient method of finding out the like similarities between two different sequences. Especially we are using it in a large scale. But the thing is that it do not guarantee the optimal alignment solution, but it is more efficient than any other method, including the dynamic method. It is more useful in the large scale database searches if you want to do the pairwise alignment between one sequence and another, but your sequence you want to compare it with maybe 10,000 sequences or the 10 lakh sequences or all the sequences present in a database. That's what we literally do in BLAST. So we are comparing our sequence we are doing the pairwise alignment between our sequence and 2 billion base sequences in the BLAST. So what we do this by word method. We are converting our query, our sequence into small words, and we actually finding the similarities of these words with the already formed words in the directory. And in some way, the Google search is working in that way, based on the depending on the words. So the word method identify a series of short non-overlapping sequences called words as a query sequence, and this query sequence is actually matched with to the database. So this one is an efficient method and effective method, but it do not guarantee the optimal solution. So those are the methods used for or algorithms used for pairwise alignment. Thank you.